All right, glad y'all are here. Glad to be back in person. This is the first reunion I've been at since pre-COVID, so good to be back in person with everybody here and have you all. So my name's Dave Gardner. I'm a database specialist solution architect with AWS, and I'm joined with Deb and Ryan from Liberty Mutual. And today we're going to be talking about modernizing applications with purpose-built database featuring Liberty Mutual's story and their database journey. So hopefully you'll get some insight into their journey and modernizing their applications and leveraging a lot of the purpose-built databases from AWS. And you can also talk about, how to get started in your own journey. So, all right, so the agenda we've got is key attributes for modern database applications and modern database architectures. And then we'll hear Liberty Mutual's database evolution and the journey that they've been on. Hopefully you can learn from that. And then we'll talk about database modernization playbooks, and then also typical modernization journey with purpose-built databases from AWS. So let's get started. So the 7 key attributes for modern applications include innovation, agility, performance, scalability, high availability, easy to manage, and cost effective. And so let's kind of go into each one of those in a little bit more detail. Just for kind of reference, like on Amazon.com, when we started our adventure on going from a monolithic application to a microservices built application, our North Star guiding thing that we focused on was really innovation. The speed and agility was lacking in the platform. And so we wanted to make sure we addressed that. And so innovation is also, if you read Andy Jassy's first letter to shareholders this past January, he talked about incremental innovation is like compound interest, right? It snowballs, it continues to give, it makes a big impact, right? And that innovation, working with customers, that's really the key thing that a lot of them want, is that compounding interest, kind of flywheel, snowball effect of being able to deliver to your customers fast. And you'll hear that in the Liberty Mutual story, where they've really sped things up, their ability to deliver to their customers. So that's really the core, and that was, again, on Amazon when they did was the innovation and agility. Performance, and so if you have a trading application, right, so latency in terms of milliseconds versus microseconds can mean, millions of dollars, right? So your architecture needs to be able to support not only that innovation and agility, but whatever your latency needs of your application is, whether it's, like I said, that trading application or, folks that use Lyft, to get here from the airport to your hotel and reinvent around. That's definitely part of their protocols to be able to answer that question very quickly. Also scalability, right? So we talked about COVID and pandemic. Some of my customers went from having to scale their infrastructure 6 to 10x, overnight. For example, Zoom's one of the reference customers we'll talk about later in the slide deck. Their infrastructure went up dramatically. Whereas I have other customers in the travel and transportation industry, and they had to scale their infrastructure way back, right? Because people weren't traveling. So that flexibility needs to be built into your architecture as well. And then high availability, making sure your RTO and RPOs are met of your application or other key attributes. And then easy to manage and cost effective, right? So at AWS, when we build services, whether it's for databases or containers or streaming or analytics, one of the core focuses is making sure that it's a cost effective service. And so if you are using one of the AWS services and it's maybe a little bit more expensive than you think it should be, we definitely want to take a look to make sure you're using the right service for the right purpose, right? So definitely contact your AWS team. We're certainly glad to work through a well-architected review with you of that. And so again, those are the key attributes for modern applications. All right, so modern data architecture, right? So on the left-hand side of the screen, we'll see the classic kind of 3-tier web architecture, right? Which in the 90s, early 2000s, this was heads and shoulders above that mainframe architecture with your vSAN files and COBOL and blah, blah. So the 3-tier web architecture certainly gave you a lot more flexibility in terms of being able to scale and some scalability in terms of web applications, application server, doing the business logic. And typically the database layer was one big monolithic database, right? So this is fairly tightly coupled infrastructure together, right? So even though it was leaps and bounds of the prior, it still had some limitations in terms of its agility and innovation that we talked about earlier that are key business impacts. And so what we see customers moving to now is more of that microservice microservices, decoupled architecture that give you that flexibility to be able to be innovative and have different parts of the application do upgrades at different times. And so you have a presentation layer, and now it's not just a web server, right? You have mobile, you've got your classic web server, you've got all the different types of presentation layer with your applications that you've got to be able to address. And then on the business logic, it's no longer the application layer. It's now both, maybe it's Lambda functions, right, where you're calling service or little snippets of code in real time to be able to process your applications. Or maybe using container service to kind of containerize some of that legacy code and bring it to the cloud or make it more modular and scalable together. And then there's also just the events logic, right? So with the microservices, there are some of the different components like messaging, like queuing, caching, things like that that are different inside that architecture than the three-tier web app, right? So we do have services within AWS to help you build, whether it's app mesh or, as I mentioned, the Lambda function containers. There's also managed Kafka or Kinesis to be able to stream and pipeline your data across multiple services and be able to communicate all those different services. So this type of architecture does give you those 7 different attributes of being able to scale different components at different times, make them cost effective, and then also have the agility to be able to change one particular service without impacting the others. All right, so let's kind of hear from Liberty Mutual and their experience with their database.
Thanks, David. I'm Ryan Costello. I'm the Director of Engineering. Been a DBA almost my entire career before I moved into management, so I'm going to tell you a little bit about Liberty's story. I got a quick slide overview of what Liberty Mutual is about, evolution of our database strategy, wins and challenges, what we've learned, and where we're going with our next steps on our journey. So about Liberty, I don't know if you guys are aware, but you may have seen our commercials with Doug and Limu, the emu. I've seen them a few times. And if you haven't, we are a huge global insurance company. We've been around for a long time, 110 years, I think, this year. Global company, 29 countries, 45,000 employees with 5,000 in the tech industry, all over the world. And we've built a lot of databases over those 110 years, most recently in the last 20 to 30. And how we manage and build those has really changed drastically in the last 5 years or so. And moving all of that data from 110 years worth of consolidations and acquisitions has been a big challenge, but one that we've been working on over the last several years with AWS. So our database lifecycle management was lengthy, manual, involved many different groups, and was not really easily scalable. In the early days of needing to provision physical hardware to house a database, it could take upwards of 4 months for the initial request for the servers to the time that the database was ready for use, and that was probably just your non-prod environment. And while this process worked at the time, it did lead to several problematic practices. We had, because it took so long, we had to provision them. We had development teams would often use existing databases to add new information to instead of spinning up a new database. So that created not necessarily monolithic applications, although sometimes that, but large databases with a lot of stuff in it that wasn't really necessarily the stuff that was supposed to be in it initially, which caused all kinds of problems from a security perspective. You're not sure if the people who are accessing the data are really the ones who are supposed to be seeing it because it's not the data that was originally in there. And it meant that there was a lot of overhead added to the maintenance processes. Backups and restores took longer, optimizing queries was more difficult, upgrades were more complex, changes to schemas became riskier, and that caused a lot of day 2 churn after we had the databases up and running. So as time went on, it obviously became a priority to provision faster and easier. The picture here, waiting for my database server, that's actually an accurate depiction of how I felt one day when I first moved into management of the database group, where I was in a large meeting with our CIO, and somebody at the back stood up and said, "When are we going to do something about how long it takes to provision a database server?" And I'm literally looking the CIO in the face, and I was like, "Oh my gosh, this is my first week on the job." And okay, well, I feel a little bit better about it now. So what did that journey look like? We started out, obviously, as I mentioned, with the physical servers. Our changes started with moving away from those physical servers, moving into virtualization, which helped reduce the amount of time needed to spin up new OSs and the hardware. On top of that, we built our database as a service offering, which contained the entire install of the database software, the configurations that we needed on our on-prem environment. We then moved that into AWS's IaaS with EC2, And then further into that, we started delving into the RDS. That eventually moved into our pipelines and even into serverless offerings like DynamoDB. So that has led to where we are today, which is we have our own internal marketplace of cloud database offerings and push-button database deployment capabilities, leveraging a lot of different types of databases so that our developers can easily build the right kind of databases easily with all of the desired security and configuration parameters already built in. And we went from essentially 6 unique database engines with about 5,500 servers and instances to now over 20 up in AWS and on-prem with over 11,000 database instances. So this is just a quick glimpse of what our internal marketplace looks like, where our developers can come and use the offerings. This is just a quick snapshot, but as we add more to this marketplace, so it's a really easy place for them to come and just click a button and get all of our configurations. And with that, I'm going to hand it over to Deb, and she's going to walk you through a couple of explicit examples.
All right, thanks, Ryan. So let's dive just a little bit deeper into our journey. I want to highlight a few of the efforts at Liberty Mutual as we moved into AWS, and we took our database deployments from months into minutes. I'm going to spotlight 3 key efforts that helped to define our journey during the last 5 years. These efforts focus on database modernization, data migration, and automation. During this journey, I wore a few different hats. First, I was a database administrator. Then towards the end, I was an infrastructure engineer. Now, I saw through the poll that several people or several of the folks that are listening in have already started their journey. And for those of you that started your journey, I'm hoping that I'm able to provide you with some maybe ideas of new ways that you can do some modernization with your applications. And for those of you that haven't started, I hope I can inspire you as well. So let's go ahead and dive in. The first effort that I want to talk about this afternoon is database modernization. This goes back to the year 2017. There was a huge project underway to update one of our claims processing systems. This system was built using the traditional 3-tier architecture that David just talked to us about, and the entire stack was ready to be modernized. The challenge for my team was moving the application and reporting databases that were located on a Windows 2000 server into the cloud. Initially, this seemed like it would be pretty easy, probably just a simple lift and shift. But as we got further into the journey, we realized that the application that we were trying to upgrade at the same time was managed by an outside vendor, and they had some pretty specific database requirements. So because of that, we thought that we'd be able to use Amazon RDS, but instead we needed to do a custom solution. So we still wanted to move to the cloud, we're still partnering with AWS, but instead what we ended up doing is actually building out an EC2 instance. We installed Oracle using custom specifications that were required by the vendor, and then we migrated the data using native database utilities. Now again, this was 2017, and looking back, I can probably come up with a list this long, maybe this long, of how we would have done it differently. But we did the best that we could at the time. It was a multi-year project, and we had involvement from a lot of different areas within the company, including our partnership with AWS to do this modernization. Even with a well-thought-out plan, there were tons of hurdles, but in the end, it was a success, and we were able to integrate with our Liberty ecosystem. So it was kind of a nice stepping stone as we started to migrate and do more modernization. The second effort that I want to look at is migrating mainframe data up into the cloud. So I'm sure many of you have mainframes, and they certainly offer plenty of challenges. At this time of the year was 2019, and we wanted to modernize one of our policy administration systems. So this is one of those systems that Ryan mentioned has been around for a long time. Tons of opportunities for us to do some modernization here. The specific challenge that we were faced with was moving mainframe data into the cloud due to some latency issues because the application had already moved to the cloud. So what did we do? We actually developed a migration strategy that broke the process into 3 distinct steps. First, we extracted and staged the data from DB2 mainframe tables into S3 buckets. Next, we used event-driven lambdas and AWS S3 architecture to parse the data. And then finally, we moved stage data into its final destination in Amazon Aurora using DMS. So again, the outcome was a success. We got our mainframe data moved to the cloud, and this was all completed without any significant outages to our end users. This, again, was a multi-year journey that helped to improve stability, performance, and reduce costs. My final effort that I want to talk about this afternoon is automating our data migrations. So now we've fast-forwarded to the year 2020. We've been able to quickly create databases. We're moving more and more applications, and they're all looking to move their data into AWS as well. So our challenge was to create a repeatable process that was a push button, that would allow push button ease to move data into the cloud. So in order to do this, we actually used CloudFormation templates, configuration as code, and we were able to quickly provision the AWS resources that were needed for a data migration. The CloudFormation templates used customization, and based on specific migration types, we were able to specify the database type for the source, the target, type of replication that we wanted to do, as well as ensure that our security, the security requirements that we have internally were managed to our standards. This all resulted in an automated data migration service using our push-button deployments. Admittedly, I made all three of these efforts sound incredibly easy, and each effort could probably be their own session here at reInvent. All of these efforts did result in successful moves into AWS while helping Liberty to progress our modernization journey. I want to quickly look at a couple of different challenges and wins that we had along the way. Challenges, I think the biggest one, and this certainly hit close to home many, many times, was the console access. AWS console access is not something that we're able to utilize within our company. So there was a lot of workarounds, there was a lot of customization that was required in order for us to be able to do many of the things offered by AWS. So that definitely falls in the challenge. In terms of the wins, though, I mean, we have configured so much through code, and everything is push-button fast, as we've already talked about today. We've continued to improve our resilience and security, and just all the self-service offerings that we have been able to provide, and things being on standard platforms. So in summary, these were all three very different efforts, but they all had the same theme. Our partnership with AWS, we've been able to deliver our purpose-built solutions. We've been able to reduce our time spent on operational aspects, and ultimately, we've helped reduce our carbon footprint as we move to more efficient data centers. Hopefully, I've inspired you with a few ideas on where to begin your journey with modernization. So with that, I'm going to turn it back over to Ryan.
Thanks, Deb. So what we've learned, this is just a real high-level pro tips. A couple of quotes here. Great discoveries and improvements invariably involve the cooperation of many minds. Really, that's just a reflection of the fact that Liberty Mutual had to really invest a lot of time and resources in this. This wasn't just one group that made it happen. We had a lot of different teams that were involved. We had network, infrastructure, OS, middleware, database, application teams, and of course, AWS. We've been partnering with them since our journey started, and they've been extremely helpful in getting us started, getting us unstuck, and helping us solve problems along the way. I think it's been a really great relationship. And the other thing, with great power comes great responsibility from Uncle Ben. Great source of wisdom there. It really is just an indication of the fact that AWS has made it so easy to spin things up that you're going to get a lot of whatever you're able to spin up. And that is something you have to be really careful with. We've deployed thousands and thousands of database instances, and then somebody eventually comes asking the question of, how many do you have? How many are big? How many are small? And it's not necessarily super easy to get at that data. So to me, we started tagging everything. Our discipline around how we actually govern all that has improved over time. So to me, that's a real important key takeaway that I've had, is really build in, as you're deploying and building stuff in AWS, is build in that intelligence to keep track of what you're building. It's going to help you down the road. So what's next for us at Liberty Mutual? We want to increase the adoption of our centrally provided database images and patterns. so that our ability to scale and ensure resiliency of our customers' data is on top of things. Right now, about 60% of our cloud databases are deployed through our centrally managed images. I really would like to get that as close to 100% as possible. We're going to continue to learn, continue to improve, and continue to drive internal innovation coupled with partners like AWS and stay on the edge of what's possible. Our goal really is to make the lives of our developers as easy as possible so that they can deliver solutions to help our customers embrace today and confidently pursue tomorrow. So thanks for that time, and I will hand it back to David.
Thanks, Ryan.
Yep.
Thanks, Deb. All right. Let's kind of move into where do you start on your journey, right? So, as a solution architect and also our ProServe team, we've helped thousands of customers, migrate their applications and databases and workload to AWS. And so, through that experience, we've been gathering all those knowledge articles and details up, and we've created database modernization playbooks. And these really sit around three common playbooks that we see working with customers and kind of trends we see out of the marketplace. The first is kind of moving to a managed database. Take that burden of managing, whether it's a relational database or a document database or a Redis cluster, move a lot of that provisioning, infrastructure, a lot of the things that Ryan and Deb talked about when they first started their journey, move all that to a managed service where it's an API call to scale things up or to implement multiple availability zones or reporting, et cetera, with the monitoring of CloudWatch. You make that an API call versus having to write all those scripts and maintain it yourself. And so moving to managed database is one of the key playbooks that we see customers doing. The other is breaking free from legacy databases. And so, commercial database engines have been around for 30 plus years. They're very widespread, very wide adopted, probably one of the more common, experience or capabilities that are out there. And so we see a lot of customers moving towards open source engines, whether that's MySQL or Postgres, and then also leveraging the Aurora engine kind of on top of those, and we'll get into that in a couple of slides. But if I don't have to pay a database license, to have a good performance database to support my application workload, that's money that I can pour back into my development cycle and other infrastructure. And then the last is the modernizing with purpose-built databases. This is really where we take maybe that legacy monolithic database or building something new, and we try and use the microservices approach to get that speed of innovation, scalability, performance, all those 7 attributes of a modern application that we talked about. And so you'll see, whether it's Oracle, SQL Server, MySQL, Postgres, and moving that into kind of more of a purpose-built database. So let's kind of talk about that journey. So migrations and modernizations are important, right? So kind of listening to the Liberty Mutual story of being able to move some things up into the cloud to get that flexibility. And I'm going to read the x-axis here because it is pretty small print, right? So on your far left, it starts with on-premise. And then we move into a lift and shift. That's where maybe we can leverage EC2 and get some scalability and very quickly scale things up and down and get a lot of that infrastructure kind of agility there. But then moving on to managed databases, right? Taking that burden of managing a relational database and offloading it to a service. And that's really where you get that total cost of ownership and that speed of innovation or innovation velocity kind of come up. And then you'll see the breaking free. And then on the far right, you've got the modernizing with purpose-built databases, right? And it really is a journey, and both of these aspects are important to your business to be able to do both, right? Whether it's kind of lift and shift to get some of the flexibility there, or start off with the modernization. And we'll get into some more details on that journey. So it is a journey, and typically most of them start with the relational database, right? So that's, a lot of those, Liberty Mutual is 100 plus years old. There's a lot of legacy databases there. If your company's been around for any amount of time, there's probably a whole host of relational databases that are out there that you're looking to modernize. But there's also some startups, right? So as I mentioned, the relational database, skill set's probably one of the most prevalent. And so we see startups start with relational databases, or they're using like an ORM, doing some rapid development prototyping. So even in startups, we'll see some relational databases that they're wanting to start on the modernization journey with that. So step 1, kind of moving to that managed database, right? And so offload the burden and the resources to manage that relational database to that managed service. This will get you some of the agility as well as ease of management and cost effectiveness, right? So you reduce that operational burden, take advantage of some platform features, right? So the DBA, one of the questions I always get as a database solution architect is, well, what about the DBA's role, right? So the DBA's role is still vital, right? But your role is going to shift from worrying about the backup scripts and maybe scaling and things like that to managing the fleet. Like Ryan mentioned, they have thousands of databases, right? So you're going to be managing a lot more databases, but the service, the managed service is going to give that capability to be able to do that, right? You're going to be able to scale yourself much more easily to be able to manage more of those databases and take advantage of that managed service that's there. And so it's also easy to adopt. And so the main service in the space for managed databases is our relational database service. It's one of the older ones that's been available on AWS. This supports 5 main database engines, right? So you have Oracle, SQL Server, Postgres, MySQL, and MariaDB. And then there is kind of 2 flavors of the Postgres and MySQL. One is the regular RDS, and then one is the Aurora, and I'll talk about Aurora in just a little bit. But the whole premise of the relational database service, working with customers and being customer obsessed like we are at AWS and Amazon, was really around making it easier to administer databases, right? So make it easy to deploy, take that 4 months of being able to stand up a new database. The skeleton guy at the keyboard, that was quite funny. And make that something where you can do it in 10 to 15 minutes, right? Also be able to make that database more performant and scalable with an API call or a click of a button is one of the other key components of the relational database service. And availability and durability, right? So instead of having to worry about, like, for example, whether it's PG replication with Postgres or data guard with Oracle, being able to click a button and say, I want this to be in multiple availability zones. Or maybe I want a cross-region read replica, so if I need to do cross-region failover, it's a click of a button to be able to deploy that. And they're also designed to be secure and compliant, right? Whether it's PCI, HIPAA, there's white papers on how to architect that with RDS and be able to meet your compliance needs there as well. So Aurora, I did mention that. And so working with customers, they're like, hey, we really like the open source databases, but we need more of performance and availability than kind of what's offered out there. And so we worked up Aurora. It's about 2016, 2017. We rolled out the initial Aurora MySQL offering and then quickly followed with the Aurora Postgres offering. But it's a drop-in compatibility with MySQL and Postgres. And really what we did, if you look at the slide, we really cloudified the storage layer, right? So it's an intelligent, log-based storage layer that has self-healing components across thousands of storage nodes. And we make 6 copies of your data across 3 availability zones. You only pay for 1. And we worry about all that storage layer for you, right? So as a DBA in past lives, right, that slow run causing performance on my database was a nightmare, right? So this is going to automatically detect that, swap out that LUN for you, and take care of that. And so it's a lot less worry and hassle on the storage layer for your databases. So it is simplicity and cost effective of the open source database with the throughput and availability of the commercial database engine. One of the features that Aurora adds in is global database. And so if I want to be able to stand up a copy of my data in a different AWS region, again, it's a click, add region, pick which region you want it to go to. Under the covers, we'll set up the storage layer, replication services, physical replicate over to another AWS storage engine in another region that you pick out. And then Aurora Serverless, that did GA earlier this year. And so that's going to give you capabilities to vertically scale your database, as well as Aurora does support up to 15 read replicas, so you can both horizontally scale for your reads, as well as being able to vertically scale those, right? So you can have a lot of fun with serverless read replicas, where I can scale out the number of read replicas, and I can also vertically scale those read replicas at the same time. So lots of flexibility that's there within the Aurora engine. So if you're looking for a Postgres or MySQL, it's certainly something to consider. So the evolution of the managed relational database service, so on the far right, we've got the RDS instance. There still is a tight coupling between the compute and the storage, right? So when you spin up an instance, RDS instance, you pick your database engine, pick your compute, and then you pick what type of storage, whether it's GP2 or provisioned IOPS, but it is tightly integrated together. And that's where Aurora really kind of our initial release of Aurora kind of separated the compute and storage. So now the storage is scalable. Again, it goes in 10 gigabit increments and scales to the storage that you need to use all the way up to 128 terabytes. And then we manage that storage layer for you. And then as I mentioned, the Aurora serverless, we've kind of done the same thing with compute, right? So now you can scale your compute up and down in milliseconds of response time, right? And so if you've got spiky workloads where it's very busy during the day when the users are running reports and things like that, and then it's very quiet on the nights and weekends, that may be a very good use case for leveraging the serverless offering there to be able to scale up and down with your compute on your Postgres and MySQL databases within the Aurora infrastructure. So definitely something if you haven't taken advantage of, maybe take a look at if you are using Aurora, being able to switch. And to be able to go from serverless to, we call it provision mode, back and forth. We call them two-way doors. You can switch back and forth very easily. It's just basically a restart to be able to switch from provision to serverless very quickly. So lots of flexibility there. So Reddit is one of our customers. It's founded in 2005, 17th most visited website. They came to AWS, we're working with AWS, says, hey, the burden of these self-managed databases is really taking away from our developers, our infrastructure team, and we'd like to find a better solution for that. And so they moved from self-managed Postgres on EC2 to Aurora. And you can see the quote from the principal engineer there. It says, we can now focus more on long-term strategic type of things versus kind of managing the database. And it made a difference in their business and capability to deliver to their customers and innovate on their behalf. So this is kind of an easy add into your architecture. So I don't have to do a complete rewrite of my application. Maybe it's just a quick, hey, I'm looking up this value or this query. I can hash that and then have that in the cache to say, okay, is this already in memory somewhere? And if so, bring it back from memory. And so kind of front-ending that read-heavy database workload with a cache is a very quick and a kind of a low-code type of modernization that you can do to your applications. You can also move those, maybe it's a scoreboard or leaderboards or offload some kind of session state. You can offload that to a cache. And so we've got Amazon Elastic Cache. And so that's really kind of the RDS service for in the caching space. And then there's also MemoryDB for Redis. But again, this kind of way of kind of offloading some of those frequent counters. It also gives you sub-millisecond data access to your data. And so the AWS in-memory managed solutions, we've got the key question here, which one's right for you, really comes down to the durability. And so, as I mentioned, Elastic Cache, there's two flavors. There's Elastic Cache for Memcached, Elastic Cache for Redis, and then there's the MemoryDB. And really, the durability is kind of the slider here that you would want to take a look at. So we've got a number of customers that are using Memcached for a key value lookup. There's no persistence, though, right? And so we'll see a lot of customers using Redis, where it does have a lot more data types, does have some persistent capabilities, also a little bit more scalability. There to be able to leverage that as a caching in front of their database or as part of their application. And then the most recent add was MemoryDB we added, and so it was actually made the Redis cache. There's actually a persistent layer, and I'll get us into a little more details of what's included in MemoryDB in a slide or two. So PayPay. PayPay is one of Japan's leading mobile payments application customers. They have like 30 million users. They wanted to be able to deploy a new capability to support QR codes, right? We've used a bunch of those in our polling sessions here. But they want to be able to deploy that in as little as 3 months. And so inside their solution, they actually leveraged Elastic Cache as part of the authentication service between all their microservices, right? So if you think about the authentication to all your API calls and all your microservices, that's a very core, mission critical type of, piece of your application, right? It also has to be very fast. And so they leveraged Elastic Cache to be able to do that because it was, sub-millisecond type of response time, and it could also scale up and handle, a large amount of traffic inside their application. But they were able to successfully deploy this new QR code capability within the 3 months and also be able to deploy that very quickly inside their architecture using Elastic Cache and offloading all that management of the Redis part to AWS. All right, so MemoryDB, I mentioned I would cover it in a little more detail. Kind of the core takeaways here is that it is Redis compatible. And so if you're using Redis today and you would want more persistence inside your caching layer, under the covers, we have added a transaction log, which is multiple availability zone aware. So if you look at the diagram, so when you do your set inside of Redis, it actually goes to the primary node, and it sends it down to the transaction log. And once the transaction log acknowledges that it's there, it is a multiple availability zone transaction log. And then we'll consider that set durably written, and then we'll go back to the application. So a little bit of overhead added to the write process. And then the replicas will be, eventually consistent, right? So it's asynchronously going to go back and update all your read replicas. But it also gives you that durability of not beyond just the in-memory of the primary instance. It is, durably written and available in multiple availability zones. So if you need more persistence inside your caching layer, this would be a good choice to be able to do that. The MemoryDB is the fastest response time database engine that we have at AWS, and so you're typically talking microseconds, so sub-millisecond type of times, and so it is very quick and very fast, and it does scale. So something to consider if you've looked at Redis and caching. Maybe look at MemoryDB as an option if you do want to more persistence layer and capabilities inside your application. All right, so step 3, this is where we start to break down that monolithic into more purpose-built databases, right? And this is where we want to get into the right tool for the right job and really drive that microservice access pattern, is going to be key for deciding which database service that we're going to leverage. And the key benefits here are really the agility, the scalability, and the performance. And so kind of looking at the bottom subsection of the graph here, that's going to be DynamoDB, DocumentDB, and key spaces. And so let's kind of jump into DynamoDB. And so it is a fast and flexible NoSQL key value lookup engine. It's performance at scale. It is a serverless offering, so there's no server to manage. It's also, you're always on the latest version, so there's none of this, oh my goodness, Postgres 10 just went out of support. I've got to upgrade everything up to 11 and figure out how do I do that. None of that with DynamoDB. It's just automatically you're always on the latest release, and we do rolling releases there. You don't have to worry about anything, right, on that part. It does support ACID transactions, encryption at rest, continuous backups. It integrates very well with your microservices architecture. Developers really like it, and so it's easy to use. It's basically define a table, define your primary key, and then get building on your application, right? For those high availability requirements, DynamoDB also supports global tables, and so you can build applications that have multi-writer, multi-region capabilities built in right into the box, right? So you don't have to worry about setting that up yourselves to be able to do that. And so it is serverless, event-driven, scalable. So for example, like today, Cyber Monday, so on the retail side of the house, we're scaling that up to millions of transactions per second to be able to support all the retail, all the purchasing for Cyber Monday and then Black Friday as well. So that's the scalability is kind of a key with DynamoDB. An example of that is Zoom. I mentioned earlier the pandemic, right? So a lot of us had to move to, having family events or office events, work events, all on Zoom, right? So their infrastructure went from, they had a 6 to 10x, scaling that they needed to do pretty much overnight as everybody kind of had to start working remotely. And so leveraging DynamoDB under the covers of their infrastructure and architecture gave them that scalability where they could kind of flip this on all by themselves, not even have to tell us at AWS, hey, we're gonna 10x our infrastructure. They just turned the capacity on and made the request, and then it pretty much was there, right? So giving that scalability and flexibility with DynamoDB is key, and it's there and kind of built in. So it does give you that scalability. The next use case for kind of breaking down the monolithics, the DocumentDB. So it's fast and scalable, fully managed MongoDB compatible database engine. So whether you've got maybe a content management solution or you're doing a lot of things with nested JSON, DocumentDB is a way of being able to offload the management of that document database to a managed service within AWS. It's fast and scalable. Very similar to Aurora, if you're familiar with that. So it's got the same kind of compute and storage are separated, and I can scale those up. I can also scale up multiple read replicas to be able to scale out my reads. It also has global distributed on the infrastructure side to where I can have, readers in separate geographic regions, AWS regions, to be able to support that. And then is also, if you have a MongoDB application, whether running on-prem or EC2, it does have drop-in compatibility with Mongo. We've got some tools that can help customers evaluate are all the APIs that I'm using under Mongo supported by DocumentDB, and be able to figure out and be able to migrate to it very quickly and easily. So if you've got a document use case, this is a good way of offloading that managed service. Or if you're looking to rewrite or modernize your application, whether it's mobile, this is a good fit for like the JSON data sets that are common practice with the developers. Key spaces, so if you're using Apache Cassandra or need a wide column NoSQL solution, Amazon Key Spaces is a Cassandra compatible database service. And again, it's all about offloading all that management of your Cassandra clusters to a managed service. Cassandra is very easy to kind of get started with, but then at scale, typically a lot of the headaches and the operational burden gets to be quite difficult. And that's where something like a Key Spaces managed service really gives you that flexibility to offload that to a managed service to be able to move quickly to that. So the specialized data interactions. So really, these are kind of special data sets and or different use cases that get supported by different different use cases, different services to support those use cases. Sorry. So whether it's social graphs, right? So I want the relationship of the data is just as important as the data itself. That's really where more of a graph engine might be helpful. Also doing like recommendations, and then you can also look at system of record, measurements, digital records. And so the benefit of these special database services, really the agility, the scalability, and the performance to be able to handle those special use cases. And so into the space, we've got the Amazon Quantum Ledger database for the system of record ledger, where you need the immutable, cryptographically verifiable log of the database to track all the changes to the data set over time. We also have Timestream, and then also Neptune. So let's jump into Neptune. And so it's a fast, reliable graph database built for the cloud. So there's no licensing with Neptune. We support the property graph of Gremlin or OpenCipher, Tinkerpop server, right, on the property graph side. And we also support the W3C RDF graph model. So if you're building graph with the RDF model, but either one are supported within Neptune. So that can support up to billions of relationships within millisecond type of latency, right? So for that recommendation engine, whether it's who talks to who, that social graph recommendation, or friends of friends, classic, the social graph use case, it certainly supports that. And we take care of a lot of that reliability, performance, and also ease of deployment for you within the Neptune service, right? So again, it's 6 copies of your data across 3 availability zones with the storage scaling. You can also scale the read replicas, and it's really meant to make it easy and powerful for you to be able to leverage graph inside your applications. And one of the things I'll go ahead and mention is that, we talked about these 4 steps, but I also have customers that have the monolithic, but they're like, hey, we really want to get into the recommendation and look at the social graph and the relations between our data. And so they'll actually start some experimenting, some projects with Neptune to be able to leverage that even before they start the modernization effort of the larger database. So it doesn't have to be sequential. You can certainly start with the key projects that, based on your business needs to be able to do that. But to Neptune, again, it's open source graph database engine. It's easy to scale and be able to find those where the relationship of the data matters just as much as the data itself. So an example of that, if you're fantasy football or fantasy sports, so Dream11 is one of the biggest providers in the fantasy sports social network service. And so one of the things they wanted to do is be able to scale to more than 100 million users and be able to look at, well, who's in what league and who's friends of friends. And so one of the challenges that they solved was they leveraged Amazon Neptune to be able to, persistently, that graph storage, to be able to look across all those, hundreds of millions of relationships, to be able to make recommendations to those and to kind of figure out how different people are connected to each other, to be able to make recommendations of, hey, your buddy Joe is also in the same league as you, and he also looks at the NBA, so maybe you should consider that, et cetera. Just kind of some examples of those types of use cases. One of the things you'll notice on their architecture is that they're also using Elasticache inside their architecture for that leaderboard, scoreboard type of infrastructure, right? So just some examples of using that purpose-built databases for different purposes and different services inside your application architecture gives you that flexibility and scalability as well as cost. So Timestream, it's a serverless, fully managed time series database. And so you don't have to define a schema up front. It's one of my favorite conversations with customers is that, okay, I've got this device data. I want to be able to load it up. You don't have to worry about defining the schema. It is serverless. It auto-scales. It has 3 separate components, the ingest, the storage, and the querying. And each one of those scales separately from the other, right? And so you can quickly define a table, start loading up data to Timestream. It'll figure out the schema, the measurements, and the dimensions for you. And then also it'll also manage what's in the memory storage layer, what's in the hard drive storage layer, and move data based on the time to live values that you set within the table. And then you can start querying on top of that with JDBC driver and ANSI-like SQL to be able to find those key insights inside your device data or time series data that you might have, right? Whether it's a desktop, or TV box top set, or it's solar panel device, or whatever type of device you're sending data, you can quickly be able to leverage Timestream to load that data up and start to be able to analyze across that time series data set for you. So, and it also integrates with the machine learning and analytics. So there's things like binning of time. And so if there's gaps in your data, it'll auto-fill that in. So there's a lot of functionality built into Timestream beyond just kind of the infrastructure to be able to capture it, query it, and manage the lifetime of the time data or the data that you've got. All right, so QLDB, this is where you need the immutable, verifiable data. And so it's basically the data is a log, right? So you don't have to worry about setting that all up in your traditional relational database. It's all done for you. And so that's Quantum Ledger database service from AWS to be able to do that. It does support Particle to be able to, like a SQL-like interface, to be able to access your data. But all that logging and management of your data and what's changing and what's the history of this data set is all captured and managed for you, right? Whether it's supply chain analytics that you want to take a look at, like who touched this particular parts that go into our final product, you should be able to look at across that time with Quantum Ledger database, or maybe it's a financial services transaction where you need to be able to verify that both parties have done their side of the transaction and then verify it and then make it available, that nobody's kind of changed something under the hood. All right, so we talked a lot about several different database services. Kind of the next step is to really unify and innovate that data together. And so kind of on the outer ring, we've talked about all the operational or transactional databases and services that you can leverage from AWS to be able to support your modern applications as well as your modernization application journeys. And then once we have all that data pulled together, we want to bring that into a data lake and be able to use that, our machine learning and artificial intelligence, to be able to really help innovate on behalf of our customers and your customers, to be able to find new insights and new products and new capabilities that they're interested in. So it's kind of like the whole unified story of both analytics and your operations together in one whole framework. All right, so to sum it up, we talked about the purpose-built modernization journey. So we talked about the 4 steps. And again, those don't have to be sequential, but typically customers start with that relational database, moving to a managed service, implementing some cache and offloading that to in-memory type of workloads, and then moving into non-relational, NoSQL type solutions, and then the specialized databases. So on behalf of Ryan, Deborah, myself, I want to thank you for spending your time with us. Do please fill out your survey. It's key for us to have get your feedback and how we can make this better, and hopefully found some good insights and nuggets to take away to start your own database journey. We'll be available up front if you have any questions. Then I'll also be at the database booth this afternoon in the expo hall if you have any questions for me. But thank you all for your time and appreciate it, and please do fill out your surveys.